as a software engineer in the releasing team, but I'm currently taking a break to work at Carbonifer. Carbonifer is a platform to measure and reduce the carbon footprint of the cloud. Here is a sentence I hear quite often. I have all my infrastructure running in the cloud, so I do not emit CO2. Yes, everything you put in the cloud disappears. It's all magic. But as you know, the cloud is powered by data centers, and data centers use electricity. But electricity is clean, right? No, not really. Let's look at some figure. We think that data centers are responsible of 20 to 25% of the electricity used by the whole digital sector. It's around 1.3% of the total electricity used worldwide. And if we look at some projections, it's showing that 20% of the electricity demand by 2030 is going to be for ICT, 20%. And the cloud is going to take a third of that. Now, if we look at the greenhouse gas emissions, we consider that the cloud is emitting a bit more than the countries like UK or France, around 300 megatons of CO2 per year. And congratulations, we currently overthrown the civil aviation. Data centers are now emitting more CO2 than the civil aviation, and it could climb to 8% by 2030. 8% is huge. It's concerning as human being, but what about as a company? As a company, we need to face regulations and compliance, and some are going to enforce soon. As a company, we want to attract ESG funds. ESG funds are keen to spend money and to fund companies that are showing sustainability. Having a nice carbon footprint could be a great tool for recruitment and staff retention. A study has shown that staff are more keen to join a company which are showing some ethics and some sustainability. It's also a good tool for customer retention, and obviously that could lead to some cost reduction. So what are we responsible of? If we take the basis, basically everybody is understanding that as a company we are responsible of basically the fuel we are burning directly. But what about the Spotify consumption? Yeah. If you as a developer need to focus using Spotify or any music streaming system, the carbon emissions of these audio streaming are there accountable in the scope of your carbon footprint of your company? Yeah, I mean, if you need it, it should be accounted. So where should we stop? Here is a report from Mozilla in 2019. They shown that 98% of their carbon footprint is the use of their product, basically the user using Firefox. So the JGIC protocol came with 3 different scopes. First scope is direct emissions, basically the fuel you are burning. Scope 2 is indirect emissions related to purchase of energy, basically your electricity bill. And the scope 3 is other indirect emissions, also called value chain emissions. For example, business travel, raw material purchase, and even the cloud service purchased. So basically, if you are running a private cloud, the electricity bill is going to be accounted in scope 2, and the purchase of servers is going to be accounted in scope 3. If you are running a public cloud, that means that all electricity is going to be accounted in scope 3. So basically the key here is to understand where to it's going to be to define the scope of the scope 3. So we have some regulation in Europe. There is the CSRD, stands for Corporate and Sustainability Reporting Directive. It's going to be enforced in 2024 for large companies and in 2 years for listed SMEs. It's going to be encompassing scope 1 and 2 and even scope 3. SFDR stands for Sustainability Financial Disclosure Regulation. It's more for financing companies, funds and investors, and they will need to account as their scope 3 the carbon footprint of the company they are investing money in. And in US, you also have the SEC Climate Disclosure Rule, which basically it's a little bit the same as SSRD, and it's going to be for scope 1 and 2 and even scope 3 as optional. So there is some terms you hear quite often. First is the CO2 offset, basically compensating and removal. So what is compensation? Compensation is basically planting trees, and removal is direct air capture, removing CO2 from the atmosphere. Elimination, on the contrary, is focusing on not emitting CO2, basically removing the source of CO2. So if a company is claiming to be carbon neutral, that means they are focusing on offset, not necessarily on emission. They can keep the same emission as usual, but they're gonna offset it, basically planting trees to offset that. If they are claiming that they're gonna be net zero, that means they're gonna focus on elimination. From my point of view, it's a bit more interesting. And obviously, there is a little bit of CO2 that they will not be able to eliminate, so that they're gonna offset the rest. If you hear about 100% renewable, you need to be careful if it's power by or match by. Power by means you are sure, 100% sure that the electron powering your data center is coming from a renewable energy source. With match by, that means, for example, if you have solar panels on the roof of the company and it's powering your data center, is powering twice your data center, which means you have a lot of electricity produced during the day, and you are selling the excess on the market. But during the night, you need to buy electricity from the market. So you might have covered your whole electricity consumption, but still you need to buy electricity on the market, and this electricity could come from the nearest coal power plant. So now, how to measure your cloud infrastructure? How a data center is working. So basically, the electricity is produced by various sources. For example, coal plants, nuclear plants. Side note: nuclear here is considered as clean energy, as is doesn't emitting any CO2, or it can come from renewable energy and even hydroelectricity. Everything is transiting over the electricity grid, the regional grid, and it's powering your data center. So if you have a cloud infrastructure, that means that you're gonna have some virtual machine, some containers, some process hosted on bits of those servers in the data center. So as a large majority of the electricity is gonna power these servers, a little bit of electricity is used for powering the computers of the office building, the heaters, the air conditioning, etc., etc. But the large majority is going to be for the servers. So basically, if you have some VMs running on public data centers, that means you could be responsible of a ratio of this electricity coming into the data center. The Green Software Foundation came up with this formula. It has been integrated in ISO, and this formula is the SCI. It stands for Software Carbon Intensity. So basically, it's how we can calculate the carbon intensity of a piece of software by multiplying the energy consumed by the software with the carbon intensity of the grid plus the embodied emission of your hardware. So let's look at the hardware first. So basically, if you have bought a server and this server required 4,000 kilograms of CO2 for being manufactured and being disposed, that means that virtually every year you're gonna emit 1 ton of CO2. So you can even calculate the ratio per hour, per process, etc., etc. So those are called embodied emissions. The use emission, so the E multiplied by the I, is the carbon emissions of your actual software, regardless on the hardware. So how we calculate that? First, we need to know how many kilowatt hour is used by a software. So if you are running on AWS M4 large instance with 2 CPUs and 8 gigabyte of RAM, and your process is using 50% of that. That means that there is some calculation to do that. You will need 10 watt hour to run that. So we multiply that by the power usage effectiveness. So remember, you have a little bit of loss of electricity when powering a data center. So for example, in AWS Ireland, we consider that the PUE is 1.2, which means that if you want to have 1.2 kilowatt hour to power your server, you might need to have 1.2 kilowatt hour. So 1.2 kilowatt hour in order to have 1 kilowatt hour. And you multiply all of that by the carbon intensity of the grid. So basically, each regional grid of the world have different energy mix, different ways of producing electricity. So in this example in Ireland, the yearly average is 316 grams of CO2 per kilowatt hour. So each kilowatt hour is gonna emit 300 grams of CO2. So at the end, if you multiply all that, this piece of software will emit 3.8 grams of CO2 per hour. We are talking here in gram of CO2 equivalent because it's not only CO2 which could be emitted while generating electricity. For example, you also could have some methane. Methane is 84 times more potent as greenhouse gas than the CO2. So in order to ease calculation, we are talking about CO2 equivalent and grams of CO2 equivalent. So if we circle back to this SCI formula, if we add the use of the energy used by your software to the embodied emission, it comes to 5 grams of CO2 equivalent per hour. So what are the easily available data? So the average carbon intensity of regional grids are pretty well known. All data centers are producing those figures. And you can also go to apps.electricitymaps.com where you have this beautiful map and you can see in real time what is the carbon intensity of local grids. For example, here in March 2022 in France, kilowatt hour required 157 grams of CO2 when this kilowatt hour has been produced, while in US it was more than 250 grams of CO2 per kilowatt hour. The power usage effectiveness, those are pretty well-known numbers, and most of cloud providers have those numbers under 1.5. There are less available data. For example, if you want to have accurate measurement of the kilowatts needed by your hardware, you need to know the CPU and the CPU manufacturer, the model, the percentage of usage, etc., etc. Those if you're running something on AWS or GCP or Azure, it's pretty hard to find this information. How you can know what is the manufacturer of the CPU or the GPU. So in order to ease that, we can use some estimation and coefficient, and most of the time they are good enough for making some relative comparisons. Same thing for memory, storage, and network. Same thing for the embodied emission of hardware. You need to know what type of hardware you are running on, where the server has been manufactured. So in order to ease that, we have some data sets available. And of course, same thing, you can use estimation and coefficient. Another thing which is quite hard to know is the weather prediction. So basically, the energy mix could rely on the weather, for example, if it's coming from the windmills or solar panels. And in 2 days, the prediction are pretty accurate, but in 2 months, it's pretty much unknown. So in order to ease doing that, most of the cloud provider came up with these carbon footprint dashboards and tools. So it's with one click, you will be able to see what is the carbon footprint of your entire infrastructure. So the granularity is pretty high. You will have those numbers per month, for example, and you need to wait a couple of months to have this data available. If you want to have a finer granularity, you can use a tool named Cloud Carbon Footprint. So basically, it's an open source tool, and it's reading the bills from AWS, GCP, Azure, you name it. So in those bills, you have what type of instance you have used, for how many hours, for how long, etc., etc. Same thing for Lambda, for serverless service, etc., etc. And they will calculate the carbon emissions for you. And you will be able to use this data in a beautiful dashboard as displayed here. If you want to be a little bit more accurate and have very fine granularity, you can use Scaphandr. So Scaphandr is again an open source tool, and it's basically monitoring the power used by the CPU by using some basically probes. So it's not calculating CO2 directly, but at least you have the kilowatt hour used by your CPU, and you can calculate the ratio per process, per container, per whatever you want. So it's not really working well for cloud directly. So it's more if you're running that directly on the server. You also have some APIs. For example, Climatic is a commercial API with a free tier where you can query what is the carbon footprint of a server, for example, M4 large instance on AWS running for 24 hours. So that will give you this number, and that will even give you the embodied emission for that. And you can even use that for different area, for example, freight or whatever you want. There is a lot of data sources. There is also this open source project named Boa Vista. So their flagship project is an API where you will be able to query basically same thing as a Climatic, like I have this type of instances running on Azure for how long, and it's gonna calculate the use emissions and the embodied emission. Be careful for the embodying slash manufacturing emissions is the emission for the whole lifespan of the project, not per unit of time. There is a lot of new projects that are coming at Boa Vista, so I encourage you to check that. Here is one of their tool in UI form. So basically the same thing, you click on the cloud provider, the cloud instance type, and it's gonna make all the calculations for you, and even the abiotic depletion potential, which is another concerning things we need to have a look at. And now my little project. So in this project I have already a small command line tool which is able to estimate Terraform project. So it's an open source tool. You are free to have a look at that and create PRs or whatever you want. So basically it's look at Terraform project. And in Terraform project, as you probably know, we are basically defining what is our infrastructure, what we want in our infrastructure. So in this example, in Europe West 9, which is the French zone in GCP, we want to have one E2 standard 2 instance. And that's going to calculate for you what are going to be the emissions of this project. So let's make a quick demo here. So if we run, so it's running basically the same way we are running Terraform. So if we are running Terraform plan, we can use Carbonifer plan. And in this report, you see that if we want to have 10 instances of M4 X large in Europe Central 1, which is Frankfurt region, it's going to emit 600 kilograms of CO2 equivalent per year. 600 grams is interesting because it's almost a flight from Paris to New York. If we are changing the region, for example, Europe West 3, which is the Paris region, and in France, most of the electricity is produced by nuclear power and hydroelectricity, so the carbon intensity is way lower. So in this example, it's not anymore 600 kilograms of CO2 per hour, but a bit less than 100. So magically, we have divided the carbon emission by 10 by just migrating to another region. So by using this tool, which is called Carbonifer, you can have an estimation of the carbon emission of your Terraform project. So it comes with a little bit of with some limitations. For example, everything which is auto scale or which is serverless for now, it's a little bit hard to estimate, but this tool is already covering EC2 and compute instance on AWS, GCP, even RDS instances, and even auto scaling groups with some assumption, of course, and GCK on Google platform. Let's go back to the presentation. So I also encourage you to check this Green Software Foundation page where you have the list, an awesome list of all the green software tool you can use to do that. So now we know how to measure it, how we can reduce it. First thing which is obvious is to optimize your software, your code, and use some green coding on software eco-design good practice. It's obvious, but most of the time, if you want to double the power of a software, you would double the size of the server it's running on. And most of the time it's working twice as fast. But first, if you want to minimize the use of resources, which is minimizing the generation of CO2, you might need to optimize your code. Another good thing is choosing the right instance. If you are in the cloud, it's sometimes useless to overcommit to use super big instances and maybe use the last generation instance. For example, Gravitron instance are way more efficient than other instances on AWS and are using less electricity. I think ARM CPU are using less than 1 kilowatt hour, while legacy CPUs are over 5. And you might want to migrate to hyperscaler or public cloud. All those hyperscalers and public clouds are committed to be net zero by 2030, and even Microsoft Azure want to be carbon negative by 2030. And that's also interesting to look at some alternative cloud providers such as Denver. Denver is a data center in France, and it's going to be a floating data center, naturally cooled down by the stream. And all those hyperscalers are working on improving PUE, the hardware lifespan, and they are more and more buying renewable energy. So basically, on premises, you are keen to you might want to have much more servers than on the cloud, and much more underused server, and on the cloud you're gonna have fewer highly used server. Be careful on the rebound effect because you're gonna save a lot of CO2, therefore you might want to add more and more servers. Another good practice is to use the FinOps good practice. So for example, if you want to reduce the cost, you might want to schedule your instances to shut down during the night, or even to use some auto-scaling groups, which are groups of machines self-adjusting depending on the traffic. So basically, the more traffic you have, the more instances, and the less traffic you have, the less instances, the less instances you will have. So in that case, you will save money, of course, but also you will save CO2 because you will use less resources. So as already mentioned, a good thing is to pick the right region. If we are looking at those numbers coming from the Google platform, in Paris, it's always the best choice on average. And finally, if you want to be a little bit fancier, you might want to be carbon aware. So carbon awareness is the ability of a cloud infrastructure to self-adjust by looking at the carbon intensity of the grid and the carbon emission of itself. So one first concept is temporal shifting. Temporal shifting is basically scheduling an asynchronous task when the electricity is going to be less carbon intensive. For example, if you are doing image or video processing or AI training, machine learning, DB indexing, etc., you are not forced to do it right now. Most of the time you can wait a little bit for the electricity to be less carbon intensive. At Google, they already tried that for their own needs with some asynchronous tasks, and they are running those asynchronous tasks when the electricity is less carbon intensive. Another thing is demand shaping. So basically demand shaping is doing more when the electricity is less carbon intensive. For example, if the electricity is emitting very little CO2, you can be very high resolution video, and you can lower your video, the quality of the video, when the electricity is very carbon intensive. Another good use case is CR servers. For example, you have some workers linked to the CR server, and you put less workers when electricity is very carbon intensive, which means that you're gonna wait a little bit for your PR to be built, but on the other hand, it's gonna emit less CO2. And finally, you can choose spatial shifting. So basically, spatial shifting is to leverage all those difference of carbon intensity and energy mix in the world. So in Hot Carbon 23 conference, there is a paper which has been released during this conference, and they are showing that basically they have two different data centers in two different regions with a load balancer. The load balancer usually pick the one which is the closest to the user, and with to minimize the latency. And with this load balancer, they choose to not pick the closest one necessarily, but to pick the one with the least carbon intensity at that moment. And by doing so, they manage to reduce the carbon emission of this infrastructure by 21% with no latency, and with to 51% with an acceptable latency. So here is my quick demo. So in this demo, I will have 3 different autoscaling groups, and on different regions, and with a global load balancer. So basically, a request coming from a user is gonna be picked by the global load balancer, and the global load balancer is gonna choose the region on a round-robin mode. And and I will add a carbon aware scaler, which is gonna basically reduce the region which are emitting the most and keep the region which is the best. In this example, Ireland is the best, so it's gonna shut down all instances in other regions. So let's look at that. So here is the endpoint of the global load balancer, and here is what one of the instance is responding. So this instance just respond, okay, here, hi, I'm from Ireland. So basically it knows where it is, and it's gonna reply as so. And the scalar tool knows all the regions and where instances are deployed. So in this example, Europe West 1, which is Ireland, is the best choice in terms of carbon intensity, and it has 2 instances. So let's hack a little bit this API, and now the scaler think that Europe West 3 is the best choice because it's emitting less per kilowatt hour. So progressively, those instances are going to move from US West 1 to US West 3. And if we hit the load balancer, at the end, we're going to see that only instances in Paris are going to reply instead. So it's still replying in Dublin. We're going to wait a little bit. So yes, in Paris, now it has the 2 instances. The 2 instances have been moved from Ireland to Paris. And if we check, yeah, now it's replying from France. So yeah. So quick takeaways. So the first thing, if you want to manage better your carbon emission of the cloud, is to collect usage metrics, then estimate the kilowatt hour based on that. Then using the carbon intensity of the grid, you can have the carbon emission of your cloud infrastructure per hour, and then you inject that in some visualization tool, dashboard, etc., to correlate, analyze, plan, etc., and come up with actions to reduce, schedule, resize, etc., according to the carbon intensity of the grid. And even if you can, bring some carbon awareness where your cloud infrastructure is going to be self-aware of its own emission and self-adjusting alongside with the carbon emissions. Thank you very much. Here are some links. Please check the Green Software Foundation website. They have a lot of very good resources. They also have a podcast named Environmental Variable. So you can find my details here, and don't hesitate to contact me if you have any question. Thank you very much.